Thank you, Dorian, and thank you everyone for coming to Secret Science Club. We are very happy to have Dr. Constantina Theofanopoulou here with us tonight for this special encore edition of Dance in the Brain as part of the Dana Foundation Neuroscience and Society Talk Series. Constantina Theofanopoulou is a neuroscientist and an award-winning flamenco dancer. She is the Herbert and Nell Singer Research Assistant Professor at Rockefeller University, a visiting scholar at New York University, and a research associate at Emory University, as well as at the U.S. Department of Veteran Affairs. She is using her experience in dance to inform research on the connections between dance and speech, and the possibility that dance therapy might improve deficits in speech, particularly among people who are coping with Parkinson's disease. She's also asking basic questions about what happens in the brain while we're dancing and how dance and movement may influence brain health and our overall well-being. Now, we would like to welcome her to the virtual stage here at Secret Science Club. Please take it away, Dr. Theofanopoulou.
Hi, everyone. Thank you so much, Margaret and Dorian, for the introduction. It is truly exciting to be able to present my work here at the great audience of the Secret Science Club. And I want to first thank very deeply the Secret Science Club and the Dana Foundation for making this very interesting talk series possible. And I really hope that we managed to make this a lecture as engaging as we made it happen in the in-person version of this lecture, where we were in New York City some months ago in a beautiful theatrical-like space where we were able to share not only research, but also some dancing. So we will attempt to do the most engaging online version of this here tonight. Thank you everyone for being here. Let me start off by saying that you might be able to see in my title here, Speech and Dance from Brain Pathways to Clinical Therapy, that I have put together these two words, speech and dance, that refer to behaviors that actually we have them in our minds most likely as really separate and different behaviors. What does speech have to do in the same sentence with dance? You might be wondering that, well, obviously we're using these two behaviors to socially communicate, but what is it that would make a scientist like me study speech and dance in the same research agenda? So partly this is the question that I will be trying to shed light on for the rest of the lecture. And let me just start off by saying that my background is actually in the neuroscience of speech. So I started working on what makes humans able to communicate through vocalizations, as I'm doing right now, what we're calling speech, or more generally language. And probably you must be picturing me in my in the early steps of my career, just scanning human brains, for example, as we can see on the left here, in an fMRI, functional magnetic resonance imaging scanner, and doing just research with humans. But basically, for most of my career, I have actually worked on the neuroscience of birdsong, because I and of course several other researchers in the past decades, we have been studying how some avian species sing in order to actually shed light on human speech. There are several similarities between how we speak and how several bird species sing, and we are leveraging this knowledge from avian species in order to understand better human language and understand how we could build important therapies for speech disorders. But basically, if it weren't for me studying songbirds, I would have never made the link from speech to dance. And here is how this actually was made possible. Well, basically, I need to first of all introduce that when I'm talking about this parallel, very similar convergent behavior between humans and other species, I'm referring to this very specialized component of what we call speech or spoken language that I will be referring to here with the words vocal learning. So vocal learning refers to this complex ability that we and only some other species have to vocalize, to imitate and learn new vocalizations when we're young and put them together in a specific sequence in order to make out something meaningful and communicate with conspecifics or even possibly with other species. And so what past research has shown is that in the animal kingdom, there is a spectrum when it comes to how advanced this vocal learning ability is. And there are several species, for example, mice here, they're considered to be pretty limited vocal learners. Namely, they use some ultrasonic vocalizations that we cannot actually perceive through our auditory range in order to communicate with their conspecifics. And even other species that use possibly more vocalizations, such as non-human primates, they definitely do not show this complex and advanced vocal learning ability that we see in species such as songbirds, humans, and parrots. And if we were to really set apart the species that show this vocal learning ability in its most advanced fashion, then the species that would stick out would be us humans and actually parrots. And I'm sure that this might not come as something surprising to the audience because we all have seen either live in person or videos of parrots communicating with other parrots in a very complex fashion, or even, of course, imitating human language, as we can see here for this with this parrot that is called Disco.
Never shake a baby bird. That would surely be absurd.
Never shake a baby bird. That would surely be absurd.
What is even more fascinating, and I believe this is the time, excuse me, this is the time that I'm able to draw this line between speech or vocal learning and dance. What is really, really impressive is that humans and parrots are not only the most advanced vocal learning species, they're also the only species in the animal kingdom with very compelling and convincing evidence that they can actually dance. And by dance, we mean here this specific subcomponent of dancing that I would refer to as entraining someone's movements to a beat in music. And so for those in the audience that have not seen parrots dancing, here is a great video that I will never get tired of watching.
Another one bites the dust. Another one bites the dust. And another one down, and another one down. Another one bites the dust. Hey, gonna get to me. Another one bites the dust.
I like this one. This is a good one. Yeah.
So this goes on for a long time, and the parrot keeps dancing and producing different movements to several different types of songs, actually. And this really ignited this hypothesis in my mind, which is that, well, is it that actually this is a coincidence? Namely, is it the fact that the species in the animal kingdom, humans and parrots, that are the most advanced vocal learning species, are also the species that have dancing abilities, reported dancing abilities? Is this a coincidence, or is this an overlap of two behaviors that could speak to how evolution worked to make parrots and humans able to communicate in such a complex sensory motor fashion? It could be, for example, that only the species that are really advanced vocal learners, and namely are able to imitate vocal sounds so well, it could be that only these species afterwards develop the ability to also entrain their body movements to an auditory input. Or it could as well be, another hypothesis would be that advanced vocal learning and dancing actually honed the same brain pathways, auditory and motor pathways, for example, that made this coevolution between vocal learning and dancing possible in these two species. And of course, that's why I started from talking about my background in the neuroscience of speech, afterwards neuroscience of bird song, and now dancing, because if it weren't for me studying other avian species, I wouldn't have been able to put these parts together and actually find out and hypothesize that possibly dance and speech have more to do. Their evolution possibly has more common paths than what has been once thought. And so, as I said in the beginning of the lecture, when we face these two behaviors, or when we hear about these two behaviors, speech and dance, we're not thinking of many of the similarities that they actually have, because speech and dance share several similarities. I will just mention here two important ones, being that both of them are motor behaviors that actually are characterized by a very tight auditory to motor integration. And before I unpack this, let me just say that currently, based on this interesting evolutionary question between speech and dance, and how speech and dance actually compares at the level of behavior, brain pathways, and therapy, I have started out this research agenda to actually tackle all these questions at these different levels of analysis. So let me start by just explaining why I and of course others see both speech and dance as motor behaviors, because basically several people to whom I speak about me working on the neuroscience of speech and for speech being a motor behavior, they say, well, you're not actually moving several body parts while you're speaking. Well, maybe you're moving your lips, but you're actually producing sound. The reason why people do not perceive speech or do not understand speech as a motor behavior is because the most complex and rhythmic movements that are happening are actually the laryngeal muscle movements that are hidden here, and we cannot see them as we speak. But with a laryngoscope and through laryngoscopy, we can actually take a peek of what's happening in the larynx while we're speaking. So here you will be able to witness what's happening in my own larynx as I'm producing a prolonged vowel sound. So imagine if these crazy movements are the ones that are happening while I'm just producing a vowel sound. Imagine what's happening right now as I'm speaking to you and giving this lecture. I'm definitely sure that these laryngeal muscle and vocal folds are just moving in a pretty crazy fashion. So I think that after this video, those of you that had doubts that speech and our ability to vocalize is indeed a deeply motor behavior, I think that I have resolved these doubts with this laryngoscopy. And of course, speech is a behavior that relies on a really tight auditory to motor integration. For example, it is possible for us to understand how much we rely on the auditory input of our own voice if we just cancel the auditory input of our own voice. For example, if we wear noise cancellation headphones, or if in some way through earplugs we just cancel the feedback that we receive from our own voice, we will be able to understand how more difficult it becomes for us to speak in a way that actually sounds understandable. And of course, dance needs no introduction for being a motor behavior. So both speech and dance are motor behaviors. And you can see here in this slide how a dancer that looks strikingly like me is trying to pull off this balletic arabesque, and how many muscles are being activated for even this static pose. Imagine all these muscles that get activated in online dancing as it unfolds. And of course, dance also relies on a really, really tight auditory to motor integration. There are different types of dancing. Some kinds of dancing, for example, flamenco, that is the kind of dance that I specialize in, really, really requires for the dancer to be able to perceive very, very precisely the input from from the music. For example, here as I'm going to show from the percussion, and there are even types of dance that do not come with live or other music. It is just the dancer that needs to be constantly perceiving even the input, the auditory input that their own footsteps on the ground generate in order for them to be able to keep dancing in a successful manner. And of course, I was really encouraged by Margaret and Dorian to even give here tonight a live demo of some of these ideas that I'm putting forward here. But I thought that it would be equally engaging, instead of me standing up to dance right now, to show this video that was actually recorded pretty recently in an event at the Center for Ballet and the Arts at New York University, where we were able to showcase some of the science and the dancing that we are doing. I'm using this video here to really show in flamenco how important it is for the dancer to be perceiving the percussive sound in order to entrain their the movements of their taconeo, or of their heel movements to the sound. So I think that with all this evidence, we can understand that, of course, speech and dance have several important sensory motor, auditory motor similarities. And so what, as a neuroscientist, what I set out to try and understand and shed light on is, well, what's happening in the brain while we're speaking, what's happening in the brain while we're dancing, and how actually do these brain pathways that support speech and dance compare. And of course, what neuroscientists and actually scientists and several other academics do in order to try and give a response to a question that they have is, we first go to the literature, and we're asking the question, has anyone ever tried to do anything similar? And of course, no one ever has studied speech and dance in the same comparative fashion as I'm doing, but there are definitely some studies that we can build on in order to help shape our hypothesis. So the bad news is that actually, if we were to follow the traditional view of what's happening in the brain in several different control of movements that are involved in speech versus in dancing, we would basically hypothesize that, well, it cannot be that there is anything similar happening in the brain while we speak and while we dance. Why? Because, for example, here in the primary motor cortex, which is this red area that you can see colored here in this brain, there is this traditional view that has dictated neuroscience for the past, I would say, century. It's about a century now, where the claim is that this primary motor cortex, which is the one that controls almost all the movements that we humans are able to produce, that this primary motor cortex is organized in a very strict and discrete fashion. Namely, it's these parts here that are doing foot, then hip, then arm, then hand, then face, tongue, and laryngeal movement activation. For example, then some areas that get activated during dancing, like hip or arms and hands, are seated really far away from what's happening in the laryngeal muscle movements that, as I showed, are being activated while we're speaking. So the first hypothesis would be, well, probably nothing similar is happening while we're speaking and while we're dancing. But if someone keeps trying and keeps looking, even in the newer studies, they will find out the following. And there are several studies that I could point out here, but I'm bringing up this one that was really inspiring. So in this study, by Wilson and others in 2021, what they did was that they had subjects with a spinal cord injury that was leading to several movement problems in these participants. And what is being done in such cases is that experimenters are placing these intracortical electrodes on these people's brains in order to try and record what's happening when, for example, they're trying to move their hand and grab a pencil, for example. And so what they did in this case, because the objective of that study was to record, encode and decode hand activity in order to help the subject with their hand movements. So they placed these electrode arrays on what was considered to be this hand area. Of course, if you place something on the hand area, you will likely get a signal whenever this subject is moving their hand. But what they actually realized was not only did they get activity signals when the subject was moving their hand, they also got a signal when this person was actually speaking, meaning that it could be that where these two electrode arrays were located, it could be that these brain regions actually are responsible, control, project to both hand and also speech relevant muscles, for example, laryngeal muscles. So these and other studies made me put forward the hypothesis that it could actually be that this deep relationship that we see in evolution between speech and dance could rely on the same neurons in the primary motor cortex actually projecting in different contexts to either laryngeal muscles in order to produce speech, or hand, at the very least, muscles in order to produce dance movements. So I initiated just the testing of this hypothesis in multiple experiments where two of the techniques that we have been using are functional magnetic resonance imaging and electroencephalography. Of course, either of them has their own pros and cons. And if we want to start with functional magnetic resonance imaging, this is a technique that it is really, really great when it comes, for example, to understand the brain activity that underlies speech relevant muscle movements, because the subjects in this kind of studies, in fMRI studies, they're lying down in a scanner and they can, of course, be speaking like the subject here that's saying thanks. But obviously, things get tougher when we want to study dancing, because dancing is not something that's happening lying down. Still, we and other colleagues have managed to propose and actually practically test protocols where people have been lying down and moving either rhythmically their hands by clapping or tapping their hands rhythmically, or even moving their wrists cyclically and rhythmically to the beat of the music, or even their legs, moving them up and down, or having a board here at the end of the scanner and moving them in a tango-like fashion, for example. So let's see how we try to identify and then compare what's happening in the speech and dance brain pathways, and if indeed, as per my hypothesis, there were any similarities that we could tap into. So in order to do that, what someone needs to do is to first off ask the question of what kind of data we can retrieve that would shed light on what's happening in the brain while people speak, namely while they speak and move their laryngeal muscles, as we saw in our laryngoscopy. In order to do that, of course, we need to have data of people producing words, syllables, sentences, etc., etc. And for dancing, as I explained, we would need data of people while they're doing several rhythmic dance movements, such as tapping their hand, moving their legs rhythmically, etc., etc. But of course, this would not be enough, because if we wanted to just compare these brain activity patterns while someone or a group of people are speaking versus dancing, we would probably identify what's happening in several other behaviors as well that we need to control of and actually exclude from this analysis as them being irrelevant. For example, we are using our laryngeal muscles in order to do several other behaviors, for example, such as breathing or swallowing. And we would not really be interested in tapping into what's happening in overall laryngeal muscle movements during swallowing, for example, and compare that with dance. We really want to focus on this speech versus dance comparison. Similarly, for dance, we need to be able to have data of what's happening in the brain while someone just moves their finger, wrist, elbow, knee, etc., etc., in a controlled fashion, meaning in this case, in a non-rhythmic fashion. So what we did was that we focused this study in this region of interest, being the primary motor cortex. And here I'm going to show you just an example of what it appears like to really map this speech laryngeal movement activity on the brain. You would get this green, let's say, activity. And here I'm bringing as an example only the comparison between the speech laryngeal movements and the hand tapping, although we run several comparisons between speech and leg, speech and hip, etc., etc. So here in blue, you can see what's happening when people are tapping their hands rhythmically in a dancey fashion. What we did next in order to be able to understand better this comparison is this green region that you can see here. We separated it out into two different regions. So these are basically all the same parts of the brain. It's just the coloring that is different, because actually this, although both the yellow and the red parts, being the dorsal and the ventral laryngeal motor areas respectively, although both of these areas are included in general voicing, just producing vocalizations, speech vocalizations, actually this dorsal area, this yellow area, is also seems to be, according to published evidence, pretty much specialized in what we call pitch production. And pitch is very important in human speech because it is actually this feature that makes us able to ask questions or to just exclamate and be very surprised about something. It is actually this very feature that enables us to say these two sentences differently. So someone could say, "Are you going to Constantina's lecture tonight?" Or, "Are you going to Constantina's lecture tonight?" So these two sentences use the exact same words. It is the pitch that was different that gave a completely different meaning to these two sentences. And so the question basically was, well, if we compare this speech laryngeal movement activity with the hand rhythmic tapping activity, would we find any overlap? Would we find any brain regions that actually could control both these kind of movements? And as I said before, what we of course needed to do, and we did, was to exclude several control areas, because we want for this comparison to only be able to reveal speech versus dance comparisons and not what our muscles are doing in several irrelevant behaviors, such as swallowing or grabbing a bottle of water, for example. And what we found, surprise, surprise, is that actually there was a statistically significant overlap between this dorsolaryngel motor area that you can see here in yellow and the hand tapping area that you can see in blue, and also this ventral laryngeal motor area and the blue hand rhythmic motor area. We were kind of suspicious that there might be an overlap between laryngeal and hand activity because of these other findings that I showed in this previous study. What we were not expecting to find was actually another significant overlap between this dorsal area that you can see better in this horizontal section, this dorsal laryngeal motor area responsible for speech laryngeal movements, and this leg hip rhythmic motor area. What this is telling me is that, well, it could be that in these overlapping areas that we identified, there might be neurons that in some contexts actually control speech laryngeal muscle movements, and in other, for example, dance context, they control rhythmic hand movements. And up here, where we identified this other overlap, it could be that the same neurons that in one context control and give rise to speech laryngeal movements, the very same neurons actually in a dancing context give rise to knee or hip rhythmic muscle movements. Of course, as you might be able to understand, this is a completely different view from the traditional view of the primary motor cortex that has really reigned on neuroscience for the past decades, where it would be completely unexpected for someone to say that, oh, I find hand activity somewhere where we were expecting to only find hand activity, or I'm finding laryngeal activity somewhere where it was expected in the past to only find hip movement control activity in the primary motor cortex. So I think that although we started off from wanting to really just understand better this comparison between the neurobiology of speech versus dance, we're also tapping into something possibly much bigger, which is that the primary motor cortex is not as strictly organized as it was once thought. It actually might be much more flexible, which I believe in and of itself is a pretty interesting idea. So let me get to electroencephalography, where, of course, the one thought that someone could have would be that, well, with electroencephalography, you just have to put an electroencephalography cap on a person's head, and this would record brain activity. Hence, this person would be able to just stand up and dance and do this much more relevant behavior compared to the behavior that we're testing in functional magnetic resonance imaging. But this is not as straightforward, because basically also electroencephalography traditionally has been used in seated subjects. Why? Because there are cables that are coming out of their electroencephalography caps that connect their caps with the computers of the experimenters. And of course, these cables are not really long to enable someone who would want to dance to just dance freely. So we so starting off from wanting to really understand better this comparison between the neurobiology of speech and dance, we encountered much bigger technological problems, which is basically, okay, how do we record brain activity from individuals while dancing? And I couldn't be happier to have found the best collaborator to pair with in this project with Jose Contreras Vidal at the University of Houston, where what we did together was that we innovated on protocols that made what I'm calling here mobile electroencephalography possible. Namely, we got rid of the cables that I showed in the previous slide. We didn't need to have cables connecting the electroencephalography caps with the computers of the experimenters. Rather, we had our participants carry Wi-Fi transmitters that were wirelessly sending their brain activity signals from the cap to our computers without cables wirelessly, as I said before. So this technique is called mobile electroencephalography, and of course, it makes studying dance much more straightforward. It makes actual dancing and synchronous recording doable. But of course, we didn't want for our subjects to be carrying around while dancing several pieces of equipment that they had to carry, such as, for example, the Wi-Fi or Bluetooth transmitters. So the idea that we found out was to empty out travel neck pillows and put in there all these pieces of equipment. And so you can see here that our dancers got trained to dance with these travel neck pillows, and they actually got really used to it, and they were even able to perform pretty complex movements such as rolling on the floor, etc., etc. Something else that is actually very challenging in electroencephalography, and partly the reason why in the past they really needed people to be seated, is because electroencephalography is very, very sensitive when it comes to picking up any different kinds of movements that the subject is performing. And of course, while we're dancing, we're not only producing dance-relevant movements. For example, we produce, of course, movements that are akin to eye blinks, which are not dance movements, right? So what we did in order to be able to record this specific activity and then eliminate it from our data in order to have clean dancing data was to add here on top and under the eye of our dancing participants 2 electrodes that were recording constantly their blinks and eye movements in order for us in the analysis afterwards to be able to remove them from our brain signal. We also placed a device here that was recording all of their head and neck movements that were possibly irrelevant to dancing. Of course, you can move your head just to the rhythm of the sound, but you're constantly moving your head while you're moving. It might be irrelevant to dancing. So we also wanted to be aware of these movements and to eliminate them from our data in offline analysis. And you can see here that we had our subjects not only dance. This is just how the brain oscillations, these brain waves look like from just several of the electrodes while one of our participants was dancing. But of course, we had them do several other control tasks, such as mere walking or sitting, or obviously my behavior of interest, which is speaking. And right now, as we're speaking, this analysis between what's happening in these different behavior is taking place. And I'm really hopeful that very soon we will have data that will unravel the neurobiology of dance in and of itself, and also its comparison with other behaviors such as speaking or walking, for example. Something that we also were able to do in the context of this collaboration was that we kind of thought that, well, if we really manage to record brain activity from 5 dancers simultaneously, then we absolutely need to make this into a live performance with an audience that will be witnessing this dancing experiment. But of course, come to think of it, it would be just the audience looking at dancers dancing, with the only difference being that they would be wearing electroencephalography caps on and these travel neck pillows with the Wi-Fi transmitters. So what we did was that we actually performed a protocol that enabled us to take this brain activity that was being recorded here and sent wirelessly to our computers, analyze this activity in real time for what we're calling interbrain synchrony, and project a visualization of this interbrain synchrony on a screen behind the dancers. So let me take this step by step. What you can see here behind the dancers is a visualization of 5 circles that actually correspond to the 5 brains of the dancer. So this is for dancer 1, this is for dancer 2, dancer 3, and so on and so forth. And what you see is that there are lines connecting the different dyads of the dancers. And these lines, in some cases, are more purple. In some cases, they are less purple and more blue. So the more purple the lines were becoming, this was signifying a higher interbrain synchrony, namely the two brains of these dancers were more synchronized compared to, for example, these two dancers that we see here, this blue low interbrain synchrony, namely their brain oscillations were not synchronized that much. And I think that this is really, really important because dancers are definitely, for example, listening to the same audio input. They're in the same place. They have been trained to dance this choreography several times together. What would be that would make some brains be more synchronized than others? What was definitely really important for us was that we gave the possibility to the audience for them to be participants not only of an aesthetic artistic experience, but also of a live experiment where they would see in real time their interbrain synchrony between the dyads of the dancers becoming higher or lower. This was a pretty important scientific feat, as it was the first time in scientific history that we managed to record simultaneous brain activity and synchronously for 5 individuals. Actually, we broke the previous record, which was 2 individuals while performing any task or specifically dancing jointly. And I think it was pretty cool to see last week and this past Sunday in the print version that this feat was featured in the New York Times. So let's get to the last component of this lecture and see how I'm actually leveraging or how I'm actually understanding these findings in the context of therapy. How is it that we can build onto this shared neurobiology of speech and dance in order to propose solutions, therapeutic solutions for people with sensory motor deficits, for example, in the context of Parkinson's disease? Because if really, as I showed that my preliminary findings are pointing to, if really there are these neurons that can simultaneously, overlappingly project to either hand or laryngeal muscles, or laryngeal muscles here in the primary motor cortex, then this would mean that by dance training, where, for example, among other muscles, you're exercising your hand muscles, it could be that by dance training, you're actually exercising these same neurons that in other contexts could give rise to speech improvement by an improved control of the laryngeal muscles here. Namely, could it be that dancing is beneficial not only for several motor disorders and several motor symptoms that we see, for example, in Parkinson's disease, could it be also beneficial for the speech laryngeal movements in the context of speech and speech deficits? And what I need to highlight here is that speech deficits are really prevalent in neurodegenerative diseases, such as in Parkinson's disease, although what we tend to highlight are actually other motor symptoms, such as tremor, bradykinesia, namely slow movements, freezing when people with Parkinson's disease walk, difficulty in standing when they're seated, etc., etc. Basically, speech deficits is part of this motor symptomatology that we see in Parkinson's disease. And based on these people's report, actually, they suffer from speech deficits at a 70 to 89 percentage of the population. Namely, it's really an important component of Parkinson's disease and of suffering that people with Parkinson's go through. And the speech deficits specifically are being characterized by difficulties in pitch production, in intensity, namely in the volume of the speech, in speech rate and articulation. And if we pair these results with results from for example, laryngoscopy, as I showed in the beginning of the lecture, we would find out that, well, people with Parkinson's disease are not actually able to do what you saw me doing in the laryngoscopy video, where I was vibrating my vocal folds really close to each other and actually sealing them, really tightly close them while I was producing this prolonged vowel sound. Actually, people with Parkinson's disease, they're not able to close their vocal folds sufficiently. They suffer from what is called insufficient vocal fold closure, which is actually giving rise to several of these speech deficits. And one important example of how a person with Parkinson's disease and speech deficit sounds like comes from, of course, Michael J. Fox, important artist, actor, and absolutely incredible activist for Parkinson's.
My life is set up so I can pack Parkinson's along with me if I have to.
You've not squandered any of your capacity. But at some point, Parkinson's going to make the call for you, isn't it?
Yeah, it's banging on the door. Yeah, I mean, I won't lie, it's getting harder. It's getting harder. It's getting tougher. Every day gets tougher. But that's the way it is. I mean, who do I see about that?
So I find that it is absolutely
My life is
important to focus on therapies that would enable us to treat or improve these speech deficits in people with Parkinson's disease. What is definitely hopeful and positive in the realm of dance training is that there are already established protocols where dancers are able to train people with Parkinson's disease in a safe and efficient fashion. One of the important protocols has been established from this initiative that is called Dance for Parkinson's Disease in the context of the Mark Morris group, where they're combining several different tools in order to efficiently and safely train people with Parkinson's disease, as you can see here in this short clip. What is important, though, is that these dance training protocols have mostly been used, actually almost exclusively been used, in any other behavior than speech. Why? Because no one so far had made this connection between dancing and speaking, and that actually it could be that through dancing, we could tap into brain pathways that also control speech. So we paired with a group from Canada, the D'Souza Lab at York University, where they followed a similar protocol that was based on this protocol that I just showed from Dance from Parkinson's disease, where people with Parkinson's underwent an 8-month dance training. And they also had their brain scanned with functional magnetic resonance imaging once before, twice during, and once after the 8-month dance training was completed. And we're just starting to analyze these results, but what we're finding is that one of the regions where we find significantly different activity is actually this dorsal laryngeal motor area. And I need to highlight that these people were not involved in any speech therapy. They were only involved in dance training. What this means is that it could be then, as we're saying here, that dance training might be really affecting brain areas that could be leading to different control of the muscles that have to do with speech, namely laryngeal muscle movements. We're also starting a collaboration with the incredible lab of Madeleine Hackney at Emory University, where they have actually generated another protocol that is based almost exclusively on tango, and is called adaptive tango, or in short, adapt tango, where in this case, the study that was run was a 12-week shorter study And it was compared in all cases in people with Parkinson's disease, 12 weeks of adaptango versus just walking. And we are now starting to understand that actually it could be that only the people that went through adaptango are showing significant differences, not in the activity of these brain regions. This was not what we were testing, but in how these regions, and specifically this ventral laryngeal motor area, is connected with other areas such as the middle frontal gyrus or the frontal lobe. So I think it is important to just putting together these two studies and other several studies that are currently ongoing to see that, well, by dancing and by actually doing exercise, practicing other body muscle movements such as hands, legs, hips, we might actually exerting some impact into neurons, into brain areas that are responsible for speech. And right now we are running several ongoing studies. I really hope that very soon I will have more data to show to you, where we're trying to bridge the gap between behavior and brain activity, and really test whether indeed this different activity in the laryngeal areas is also paired with an improved speech performance. Is it really that dancing helps people with Parkinson's or Alzheimer speak better and overcome aspects of their speech deficits? Of course, as I briefly touched upon in the beginning of the lecture, this was a coincidental finding for me, and it really depended on me finding myself at the right moment, at the right place where these findings of the parrot came out. For me to put together several of these pieces and study comparatively speech and dance. As before that, I was actually both a neuroscientist and a dancer, but I was doing these two different things. I was expressing these two different passions in completely different settings, maybe at the lab or at the theater. But what's happening now, after having realized that possibly these two behaviors are very well tied with each other and could speak about the evolution of complex sensory motor communication in humans and other species, well, I'm mostly doing both of them in both spaces. And you could either find me dancing in the lab or generating dance protocols for people with neurodegenerative disorders, or even giving scientific lectures and afterwards dancing to just showcase several of the observations that I'm talking about. Of course, science is a team effort, and I would do a disservice if I was not deeply thanking all the important mentors, mentees, collaborators, and human and non-human participants who took part in these studies. I have just listed here some of the important collaborators for ongoing past or future studies, but there's so many more. And of course, all this research would be impossible without the necessary support. And of course, we wouldn't be so passionate if it weren't for great audiences like this one, that I'm feeling the vibes of the attention that you have been paying to this lecture. Thank you so much for your attention. I appreciate very much that you dedicated this Wednesday night to science. Thank you.
Thank you so much. That was a great talk. Constantina Theofanopoulou, and we want to open up the floor, as it were, to questions. I've gotten several sent in to me, so again, people can raise their hand if they have a question, or they can send them in to me via the chat. And the hand raiser is down there, and the chat is down there also. And I want to also add that I've put a free share link to the New York Times article about dance and neuroscience in the chat, so if you look in there, I put a link in there for people to use. Okay, so on to the questions. Opera addict Jeff asks, is there a difference in brain function during singing as opposed to speaking?
So there are very important similarities, and of course there are also differences, because singing taps more into this pitch module that I was talking about. We definitely need to include singing as one of the relevant tasks when it comes to comparing speech and dancing. I think that definitely singing would be another important component that we should add in the analysis. And someone could even say, well, since singing is actually more rhythmic compared or more regularly rhythmic compared to speaking, it could be that actually the similarities and the overlapping brain pathways between singing and dance could even be more pronounced. So to be studied, it's definitely one of my interests, and I'm trying to take things one thing at a time in order to understand the brain as best as possible. Thank you for this question.
Okay, we have Ash who has a question. I'm going to ask Ash to unmute and ask your question.
Thank you. Very enlightening talk. Appreciate it. You talked quite a bit about encephalography, and I was wondering, did you ever have a chance to transpose this using the delta waves which we produce during our sleep, the theta waves when we produce them after a nap, and the alpha waves which are basically for sedating and calming us down? And of course, the most important, the gamma waves, which are produced during the aha moment, like hooray, aha, yippee, yahoo. And this could do a whole lot in the treatment of depression and anxiety. I was wondering if you had a chance to touch on this. And the second part of my question is the Parkinson's disease regarding the dancing plus singing, because singing, it involves the vocal cords, and the vocal cords are supplied by the vagus nerve and its branches. So when you combine both dancing plus singing, it might have a much more profound and better effect, especially when it comes to speech.
Yeah. Thank you so much for these questions. I need to say, as of the first question, that in the context of the electroencephalography experiment and the live visualization of the interbrain synchrony that I showed, we based this interbrain synchrony analysis only on the gamma band, on the gamma oscillation. Why? Because it would take a lot of computational space to actually run a fully fledged analysis involving all the alpha, beta, delta, and other brain waves. So for the online real-time visualization that I showed and these lines connecting the brains, they are based on only this very fast spiking gamma activity. Right now, in this offline analysis that we are running with the piece of time and computational space in our computers, we can start, and we have started looking into other oscillations, for example, delta, theta, et cetera, and the how phase locking or amplitude synchronization is happening in these other oscillations. So I really hope to be able to have news about this very soon. And I definitely think that dancing could be viable for several mental health issues. For example, you mentioned anxiety, and as of now, I think that I'm trying to really focus on this motor component in order to make this program focused, because I have realized that if we try to do too many things at the same time, then everything gets much more difficult. But definitely it's in the agenda list for the next years. Now, when it comes to the second question, and what if we combine dancing and singing? Would this have even more pronounced effects? I definitely I'm not saying that we should take out of the program any speech or singing therapy. What I'm trying to say is that one of the therapies that these people with Parkinson's disease are already involved in, we could actually repurpose it. We could actually use it also and understand it better in the context of another behavior, because there are, for example, in Dance for Parkinson's Disease, the Mark Morris group is already offers classes to people with Parkinson's once a week, and this once a week timing actually gives rise to important improvements in several motor deficits in several other body movements, such as walking, the freezing of walking, et cetera, et cetera. So how would that be if actually we assessed what this same class is doing on another behavior, being the speech behavior? I definitely think that combining dance and speech could even be better, but what several patients are actually complain about is that they have a very huge burden of too many therapies, physical therapies, occupational therapies, speech, dance, even singing, that this actually takes up a lot of the time. When it comes specifically to speech therapy, patients also complain about speech therapy being very, very repetitive and not taking into account this functional, like social communication part that that they, like would really want to improve on. So it's really just more articulation exercises, drills, et cetera, et cetera. So we really want to make this experience also kind of more pleasant, practically more pleasant for the individuals. And singing possibly comes closer to a more pleasant therapy versus speech therapy. So I think I'm just, like trying to say that repurposing dancing would limit all the hours that these patients would have to attend for different sessions, and it would be extremely interesting because it would show how flexible our brain is. But definitely combining with other practices would be absolutely welcome. Thank you very much.
Okay, we have another one sent in by Cookie. Would studying hand and body gesturing, which is sort of in between speech and movement slash dance, have any relevance to the connection, or like body language, especially as employed by animals and is often very expressive and can be used as a threat to get a mate, etc.? Also, would the study of the neuroscience of sign language have any relevance? Again, it's in between speech and movement, not dance, but coordinated movement.
Yeah, I think that you're touching upon something very, very important, which goes back to the Darwinian theory of the hand proto, let's say, language, or that we humans were using as our very close relatives, non-human primates, that are using mostly hand gestures for their communicative purposes, that we were actually using mostly hand gestures as well. And then we also added up the vocal component, and hence we have language. So I definitely think that, and what has been proven in several studies is that the rhythm with which we move our hand gestures while we speak actually is coupled with the rhythm that our syllables are being produced. What this means is that we're talking about two systems that are synchronized, and motor movements that are synchronized. And definitely it could be that because these two types of movements, and we're talking about now, for example, hand and larynx, these types of movements kind of got honed together to be moving in similar rhythmic frames. It could be that actually they were evolution tinkered into them into just, like producing more specific rhythmic movements for dancing. So I definitely think that hand gestures are important. This is another component that we want to include in future studies. What's happening in hand gestures? What's happening in hand gestures alone versus hand gestures during speech? And also, of course, sign languages. How different is that? We are really, starting to understand some similarities between motor pathways that were considered very, very different. And all these thoughts are in my mind, and hopefully I will address them sooner than later. Thank you.
Well, sounds like a very rich field that you've wandered into here. I think we'll be able to have you back several times. Mr. Moore here has a question. I'm going to ask Chris to unmute themselves. Chris, are you there?
Yes.
Yeah, there you go.
Hi. I'm a speech language pathologist. And unfortunately, I don't get to work with Parkinson's patients too much, but I do sometimes get stroke patients. So I was wondering if you had any insights into that. Like, I don't know, versus in the Broca's or Wernicke's areas of the brain, if the dance would help with those areas at all.
So we have not looked into these areas, but what I can say is that a close colleague of mine called Stephen Brown has looked into what Broca's area is doing in several different tasks, including speech and other tasks that include hand movements such as drawing. So Broca's area, for the rest of the audience, has been found to be mostly involved in speech preparation, namely what's happening in our brain just some milliseconds before we start speaking. And so for a long time, and of course, building on these historical studies by Broca and other scientist studies, and of course, afterwards, the theoretical background of Noam Chomsky and others, Broca's area has been thought of as really like a language area. What other studies are showing is that Broca's area is actually involved in overall motor preparation. Namely, could that be then that during dancing, Broca's is involved in motor preparation of rhythmic movements? I would be surprised if it weren't. I would really be surprised if it weren't, because we see it popping up in several other tasks that are relevant with any basically kind of movement, specifically for complex movements. So I think I haven't had experience, or I haven't studied patients with strokes. What I think is important in the case of strokes is that there is this important ability for plasticity and reorganization of the brain if, as you of course should know, if the therapy is done in a pretty strict and short time window after the stroke. And I think that what my studies could, how my studies could inform your question is that, well, if indeed, even in healthy individuals, there is this flexibility in the primary motor cortex at the very least, where a neuron that controls laryngeal muscle movements also controls hand movements, et cetera, then of course it opens a window for reorganization, plasticity after a stroke to be much more doable. If you think, or if you buy the idea, the more traditional idea that the primary motor cortex has this very discrete organization, and if you mess up with the hand area, then your hand movements are gone. Then, well, you will not be so prone to believe or to test hypotheses that would enable for this area to be reorganized. I hope I answered to part of the questions. Thank you very much.
Thank you for that question. Teddy asks, I read that you started dancing at a very young age and did different styles of dance. What specifically drew you to flamenco? What spoke to you about it? And how do you feel when you're dancing? How is that feeling different from doing other activities like swimming or walking?
Oh my goodness. Okay. These are very nice questions. So thank you. What drew me to flamenco? Indeed, I started dancing from an early age. I started by doing ballet and modern dance. Very quickly, though, I started doing flamenco because my father had happened to do part of his studies in Spain. And he, although I'm making fun of him for this, he also has been dancing some flamenco and taking some flamenco classes. So he told me, why don't you start flamenco? I think you will like it. And what basically happened was that as soon as I started dancing flamenco, after this first year when I was doing both or all three, ballet, modern dance, and flamenco, I just said to my parents, because I was very little, I don't want to keep doing anything else. I just want to do flamenco. This is what expresses me. This is what I want to do. And so this was just, like, as we say, love at the first sight. This is what happened with flamenco. After that, I've done several other kinds of dancing, like contemporary dancing, even salsa, bachata, and other kinds of dances. But flamenco is something very, very, very special for me. I think that what drew me to flamenco was the impressively complex rhythmic patterns that a flamenco dancer has to learn and follow. If someone Googles flamenco rhythms, genealogical tree or something like this, they will see that it is a tree full of branches that speak to histories of different rhythms. And someone, in order to fully understand and dance flamenco, needs to get trained on these different rhythms. So I think that this complexity drew me, and the fact that it was not most of it 1, 2, 3, 4, 5, 6, 7, 8. I think that this really drew me a lot to flamenco. And of course, the fact that I feel that when I'm dancing flamenco, I'm kind of closer to the earth and I'm more grounded. One of the first things that that flamenco instructors say to people coming to their classes from ballet classes is that in ballet we tend to be all up, right? While in flamenco you have to be grounded down. So probably this grounding is metaphorically also helping me. And how I'm feeling while I'm dancing, I will just say that I'm feeling that I can fully express myself in a way that I cannot express myself in possibly any other life expression. I think that I can really let myself go, and I tend to say to people who think that they know me well that, well, you haven't seen me dancing, so you really don't know the entirety of me. And I really love other kinds of exercise that are not, like rhythmic, like as you mentioned, swimming, walking, running, Pilates and yoga that I do also very, very passionately, actually. But what I don't find there is this thing that just makes me feel that there is some interactive component there with the music, even if I'm dancing alone. And actually flamenco is a pretty solitary dance, because what people tend to respond there is that, well, I socialize with the salsa community or other communities, and this really just elevates my feelings. What I feel that I'm doing is that I have actually a loving interaction with the rhythm, and they are my life partner, and they will be. And they will be there. So I think that I keep building on this relationship. So thank you for this question.
Thank you, Teddy, for that question. We have Bama next, who has hand up. You can unmute.
Hey, hi. Thank you so much for being here tonight and sharing with us your research. I'm also a scientist at NYU, but I don't study neuroscience, but I do cardiovascular diseases. But I've got very sweet spot for neuroscience, and this is one of my favorite things to do whenever there is a secret science club. I'm zoomed in. So thank you for the organizers as well. So I have two questions. So first is that you've elegantly mapped the regions of the brain to look at regions of professional dancers, actually. As people have, they've been trained to dance, they know. So have you conducted any studies on like social dancers? When I go to parties, I love to dance. I'm definitely a very bad dancer, but I'm just wondering whether, like people that haven't accustomed their brain to dance, what if you have any insights on that? And second is, so to dance you need to listen to music, right? So what about people that are deaf? How are these circuits? How does this function in them?
Perfect. Well, thank you so very much for these questions. So first of all, indeed, the study, one of the studies, and specifically the electroencephalography study, was done on really very well-trained professional dancers. So with this study so far, we, of course, we would be tapping into the more professional or trained dancing brain. But with in this fMRI analysis that we run, the participants that were included we're not actually professional dancers. And of course, someone might say, well, okay, in order to rhythmically just clap or tap your hands on a surface, or just move your legs, maybe, of course, you don't need to be professional. And but I think that at the very least, this also speaks to the fact that these people were not trained. They were not professionals, and we're still finding these important overlaps. Having said that, it is indeed the case, and it has been found in a study where they were comparing differences in the white matter tracts between professional dancers and just, like regular people who have not danced professionally, and they found that there are significantly different changes, and the dancers have really bigger white matter tracts between several parts of the primary motor cortex and areas, for example, in the basal ganglia. So I think that there are differences, and in order to be very, very specific, we would need to have both populations. So as of now, with the EEG, we have the professional, and with the fMRI, we have the non-professional. So we'll see how the data compare. And I think that the most elegant way to do it would be to actually have these two populations in the same methodology, be it EEG or fMRI. Now, what's happening with people who are deaf while they're listening to music and dancing? So I actually, from personal experience now, and not so much as a scientist, I've had friends who are deaf, and they were going partying with us. And I remember very specifically when we were younger, they were just, like the first ones to say, oh, like this DJ is playing there, we should go and dance. And although they could not hear most of the part of the music, they could actually feel the vibration on the floor. And so they were entraining their body movements to the vibration on the floor, which is a completely, not a completely, but it is a different kind of input. So we would be talking then about not auditory to motor integration, but something like vibration, tactile, sensory to motor integration. So I think that, again, it is very interesting to see how flexible the brain is, and how people who cannot hear or have limited hearing, there are other ways for them to engage in universal human behavior, such as dancing. So yeah, thank you very much for this question.
Thank you, Bama. I relate to Bama. I am unchoreographable completely. Victoria has a question. Have you seen any promise in dance therapy for involuntary movements in Tourette's or chronic tic disorders? What kind of doctor would someone go to for help with this?
I think, so I have not studied Tourette's or chronic tic disorders. So, and as far as I know, although I have really scanned the dance literature, I cannot recall of any study that has investigated dance training in the context of Tourette and chronic tic. There might be, but it hasn't fallen into my radar for sure. So I wouldn't be able to give a response to this question. I would say for sure that, as in all cases, of course, I'm not saying that people that think that they have Parkinson's and seem to have some of the symptoms, that they should just start dancing. I think that, as everyone, of course, I would say that they should go to the relevant medical doctor, get diagnosed. There are so many powerful diagnostic tools out there that would be able to classify as best as possible its disorder to the specific disorder they belong to, and then give specific ideas, proposals for treatment. But having said that, I definitely think that the one doesn't exclude the other, meaning that now there are very active efforts for all of these all of these initiatives, such as Dance for Parkinson's Disease, to be paired with specific doctors, for example, at NYU Langone, and for these doctors to be able to inform their patients about the possibility to do dance training. So I wouldn't be, I would keep my hopes up that by even following the I would say traditional way of wanting to be diagnosed and wanting to get a doctor's opinion, that it would one way or another lead to something relevant. And if this is dance also for Tourette's, well, let it be, and that would be great. Thank you.
Okay, thank you for that. Let's see, Dr. Tina, you can unmute and ask your question.
All right, thank you for taking my question. I'm really enjoying this topic, partly because I'm a neuroscientist by training, I'm a dancer, and I am a speaker too. So it's all very relevant to me. And I remember actually back in the early, 2000s, when the first time I saw a poster on dance and Alzheimer's disease, and I was like, yes, they're right on it. I'd come up, had that hypothesis as well. So it's nice. I felt like that was like where it all started. And so it's really nice to see how far it's come. I have a few questions. One is that I would like to, I'm not really up on the literature with regards to the benefits of dance for Parkinson's disease. I've seen a lot of programs, but I haven't heard about the outcomes associated with that. And then the other question is, with dance, there's I think the main variables that are beneficial for the brain are the social aspects, the cognitive and the physical, right? But are you doing different things to control for all those aspects? I'm thinking like, okay, what's the difference between improv versus a coordinated group? Maybe there's some aspects about that entrainment that's even different from those three variables that may be important, right? And so, I'm sure people are going to ask you, how is this different from exercise in terms of how it activates or affects speech, the motor cortex. So yeah, if you could talk about that, I appreciate it. Thank you.
Of course. Thank you so much for this question. So there is actually a good literature. Of course, it is a field that the neuroscience of dance or dance training for disorders. It is a field that we're just trying to bring it up and raise it. So it's not that it's been going on for decades. It's pretty new. But although it is new, there is published evidence that in Parkinson's disease, for example, after 12 weeks or so of dance training, there is significant improvement in for example, the tremor, the hand tremor, or what's happening in people with Parkinson's disease is that as they walk, they might freeze and not be able to start walking again. So they found that this freezing part got significantly diminished after just some weeks of dancing. Another thing is balance. So there is this famous Berg balance test that has been involved in studies with dance training for Parkinson's. Balance is also significantly improved. Another difficulty in Parkinson's is the extent to which they can stand up from being seated down. This has also been shown to be significantly improved, and also mostly from self-reports in the social realm, they do feel much better. So also in these kinds of questionnaires that of course are self-reports with their own disadvantages, but what they report, the patients, is that they do really feel much better psychologically, emotionally, socially, etc. I believe that there are also some studies that are also addressing several memory issues and how memorizing a choreography can actually help you have a better memory when it comes to remembering the list of the groceries at the supermarket. So these are also other components that are being studied. So yeah, these are the ones that I could remember from the top of my head. There's definitely much more. And when it comes to our studies and how we're controlling for different kinds of trainings and other behaviors that might be going on. So in in some of the studies that we're running in collaboration with Emory University and the US Department of Veteran Affairs, in one of the studies, we have a control group that, as I said, is doing walking instead, like the same time that one group is doing dancing for the same amount of time, the other group is doing walking. So this is some, a physical exercise that is not rhythmic and doesn't have all these other features of dancing, but it is some kind of movement physical exercise. In another experiment, another control group is doing what we call education group, being that they are in let's say a lesson, a class setting, and they hear new information about several different topics. They're able to ask questions. So in this way, we can control, for example, for the socialization aspect. So these people socialize. They're in a social setting. Is it that dancing has these effects just because people feel better because they're doing something social, or is it because of the dancing? So in this way, we're able to kind of control the social component, even control this component of, oh, these people are receiving new information. They are updating their knowledge. They are updating possibly their memory skills. So we're able to control for several of these factors in this way. Obviously, in an ideal study, I would have for sure a group that would just perceive music, and possibly the same music that the group that is dancing is perceiving and dancing to. So I would have like a music, as we call it, music appreciation group, a group that would just chat and be in a social context, a group doing something that includes movement and art, something like drawing. So I would include all these different control groups if I were able, but of course this would require a study of about 250 people, and by funding limitations, this would currently, I believe, be close to impossible. But I want to be hopeful and think that at some point we will be able to run this super duper study. So far we are controlling for these different aspects that I mentioned in the ongoing studies, which for a first take, I think they are cool enough. So let's see how this goes. Thank you, Tina.
I'm going to check with you and see how your time is doing, because I know you.
How many questions do we still have?
Well, there are a lot, so it's
Okay, I
we
would
can
say
keep going, or
I would say let's do 3 more questions.
okay, that sounds good. I have one from Barbara, who says, I'm interested in hearing your thoughts about what the relationship is between one's ability to learn a dance movement almost instantly upon watching and be able to reproduce it immediately after seeing, but not, say, the next day, and one's ability to remember what you've just heard and repeat it immediately, but not the next day.
Right. So so basically the difference between just mere imitation right at the moment, but not being able to recall either how you did it or to actually do it the next day. So I think that for sure we would be we would have to take into account here several memory aspects. So maybe working memory or even short-term memory is actually very, very good in some individuals, but maybe not that great. But maybe they're not that great in what we call long-term memory. Of course, there are several other systems that are included in this kind of imitation. There is this famous mirror neuron system where we can actually copy very well what we see, or even when someone, and we can see it in very simple behaviors. For example, when someone is yawning, we tend to yawn back. So we even see that in very spontaneous kind of imitation of movements, and it happens in even voluntary movements, such as imitating a dance movement, as you said. I think in this case, we would need to test for example, in the therapeutic context, how people remember choreographies on the next day. In one of these studies that I showed that we were running, actually individuals that were sitting in an fMRI scanner, we had told them, we had instructed them to be thinking that they are actually performing the choreography as they were listening to the song that they had practiced for the past 8 months, in order to make sure which of those were doing the right thing at the right time. We were pausing the music and asking them, okay, now what are you doing? So if they were saying the correct thing, like now I'm raising my my right arm, then we were grading their behavior or their performance as, you know, like an improved, let's say, performance if they were remembering the choreography. I think it will be difficult to test this, but just my first guess would be that memory is a player there.
Thank you. Oh, Jess has a question. Thanks for such a stimulating and interesting talk. I'm wondering if you think the activated brain regions in the primary motor cortex that respond to both larynx and hand or leg movements are due to the same neurons or different neural populations that are interconnected. Do you see differences in the activity patterns when these brain regions are activated by hand versus larynx motor movements? And also, I'm wondering if the increased interbrain synchrony you saw in dancers corresponded to similar motor movements. What factors correlated most to the increased interbrain synchrony?
Right. So for the neurons, so that's a very interesting question, because of course with fMRI, which is in between the techniques that I'm using, fMRI is really best for space specificity. And even if it is much better than electroencephalography, namely you can narrow down on a very specific part of the brain and what's happening there, still it doesn't give us information at a neuronal level. Namely, it doesn't say, oh, this neuron is doing this neuron is doing that. It gives us information on much bigger groupings of neurons that we are calling in the fMRI jargon, we're calling voxels. So the kind of overlap that we're finding is at the level of voxel overlap. So this group of neurons overlap with these other groups of neurons. What's telling me, though, that we might be talking about the very same neurons is, first of all, this study where they had electrode arrays where single neurons in this case can be recorded. So if in this experiment they found overlapping activity for speech and control hand movements, then I believe that it could be that I'm also kind of picking up on similar activities. I also base this hypothesis on findings from other species, for example, of zebra finches, which are, of mice in particular. There are other studies with the zebra finches of mice, where a very recent experiment that has not been published yet, but it is available on bioRxiv, what they did was that they injected a virus on the hand, the forelimb, and the laryngeal muscles of mice in order to see where this virus would end up where the virus would end up in the primary motor cortex. This is a technique that is being used to trace projections from some muscles, like forelimb muscle or laryngeal muscle, to the brain. And what was found there was that actually in some parts of the primary motor cortex, up to 20% of neurons actually send projections to both the cricothyroid, namely laryngeal muscles, and the forelimb muscles. What this is telling me is that what we are finding in humans is not something completely new. It is not that in human evolution, there was this completely novel and revolutionary way of organizing the primary motor cortex. This is something that we see in other mammalian species, such as in mice. What could have happened in species like humans and parrots is that in these already existing overlapping neurons for that control several different muscle movements. It could be that these neurons actually hone their abilities to also control very rhythmic movements, as are the movements that we use in speech and in dancing. So I do believe that it could definitely be the same neurons that we are finding in this experiment. And now about whether in the electroencephalography experiment we are looking in the interbrain synchrony movements, namely synchrony coming out of the movements, I would say that the very, like, a starting broad answer would be we don't know. We need to run very specific analysis in order to decipher these. And we have run several control tasks of these dancers only listening to the music they were dancing their choreography without listening to the audio in order to see what's happening only with these movements. But when these movements are not being done in a dancey fashion, the dancers performing some control movements, etc., etc. So we did all these kinds of control tasks in order to see what's specific for dancing, what's also shared with other behaviors. So I would bet, of course, that what we see this interbrain synchrony, of course, is signal that the electroencephalography is picking up that has to do with movement, because basically these dancers are moving. They're not doing too many other behaviors. Of course, they're breathing and they are blinking, as I said. So there are other behaviors going on, but the basic behavior is the dancing. So for sure, we're seeing some motor synchrony there, but we would need more specific offline analysis to address this question. Thank you. Thank you very much.
Okay, we have the final question, and this is something for everybody. And this is from Vivian. It says, I know you're not a medical doctor, but if you were to write a prescription for dance in order to improve mental health, what would it be?
In order to improve mental health. Okay. So, yeah. Okay. First of all, I would say that from my reading and understanding of the literature, I definitely believe that dance would be good for several mental health issues. So first of all, I would be open to writing this prescription. How I would write this prescription, I think that when it comes to mental health issues, what is important is understanding what will be helpful to this person in a really personalized medicine fashion. Namely, it could be that for me, dancing 3 times a week is actually really motivating, just pleasant and great, like for my body, brain, etc., etc. It could be that for someone else, dancing 3 times a week could be truly exhausting. That it could be demotivating. It could be that they would not see as much, let's say, progress by doing this kind of dance training treatment. They would probably like more or less than me for different reasons. So I would be very careful about the dosage. So as it comes with as it happens with every drug prescription, one important thing, of course, is the dosage, which in this case translates to, okay, how many times per week, and this, like single class, how long should it be? For some people, doing a 1-hour class is too long. So, are there options for 30-minute classes? So duration and frequency would be one component. And then another thing would be, of course, the length of the prescription for it to have some expected effect. Namely, would I expect to then run a questionnaire or some other behavioral test to this person after 10 weeks, 12 weeks, 4 months? What would be the expected length after which I would expect to see some changes, some significant or non-significant changes? So this would definitely be some components of my prescription, and I think they would differ based on the person, their background, the time that they've felt they've suffered from mental health issues, other personal health characteristics that they have, and so on and so forth. And hopefully I covered part of this question. Thank you.
Thank you so much. I think dancing is probably good for all of us at some point. Maybe even if you just do it while you're in your home, probably.
I believe.
And we want to thank you for a fascinating talk and your great answers to the questions. Constantina Theofanopoulou, we're really excited to have you back here, and you have even more research, and it sounds like you're going to have even more next time we have you back.
I really hope so. Thank you so much for this organization, Margaret, Dorian. Keep it up, and we'll be following your work here. Thank you, thank you so much. And also, I'm really thankful to the audience and these incredible questions.